This Newton cradle thing that you seem to be struggling with. Just say we've got a one mass and a 3 mass, so the 1 mass is coming in, it's going to collide with the 3 mass. Just say it's going 10 meters per second as it collides. We know after collision that obviously the 1 mass will go this direction at half the speed, and the 3 mass will also go in the opposite direction with the same half speed of the initial incoming speed. So we'll look at that in terms of momentum and in energy, because in a Newton's cradle both momentum and energy are conserved. So the momentum side of things seems to be a bit confusing to you. The energy side of things might be a little bit simpler to follow. So in terms of momentum, we've got the 1 mass coming in, and just say that's achieving 10 meters per second, 10 miles per hour, whatever you want to say. So 10. So it's mass times velocity. 1 times 10 equals 10. So that would be the initial amount of momentum. After collision, the 1 mass goes back at half the speed. So that'll be half of 10, which would be 5. And the 3 mass goes back up in the other direction with half the speed. So 1 times 5 would be 5. 3 times 5 would be 15. We take that from that because obviously they're going in opposite directions, and that gives us as initial momentum. So momentum's conserved, not a problem, and that's how it works. So if we look at it in terms of energy, we can halve the mass, obviously. So as initial, we halve the mass, we square the velocity coming in at 10. So as initial energy coming in would be 50. After collision, we know the 1 mass will go back at half the velocity, so which would be 5. So 5 squared would be 25. So that gives us energy of 12.5. And the 3 mass would also be going half the speed of the initial, so again at 5, so half the mass times the velocity squared, and that gives us 37.5. And if we add those two together, that comes to 50, which is the initial energy that the 1 mass came in with. So energy is conserved, no more, no less, no free energy. You can add those together as well, you don't have to subtract them. So but both momentum and energy are conserved.